today we are going to learn about how we can run the Synopsys VCS tool. What are the steps involved to invoke VCS tool along with the VERDI? So the very first step that we have to do is that we have to create an environment which can be by any name, but in our case we are taking a name as env_file. So which must have the path of the installed path of all these three tools. What are these three tools? Novas, then VCS, and then the VERDI, right? So VCS is the tool which is responsible for compilation and simulation of SystemVerilog or Verilog codes, right? Whereas VERDI is a tool which is a GUI-based tool which is used to see the results in the waveforms and the schematics, and the debugging part it deals with. All the results that are being generated by the VCS needs to be seen, or you can say the debug, or you can see the waveforms and the schematics. All that you can see here is in VERDI, right? And NOAS is the supportable tool of VERDI and VCS both. So once we have set the parts of these three tools, then we have to invoke a terminal, and then we have to source this particular file. I'll show you all the steps in my server also, right? So now from the same terminal, what you have to do is you have to just write this particular command and then run if you want to run a particular file in SystemVerilog, right? And then once you have run this particular statement, then ultimately your simulation will take place. And once the simulation is successful, you will get to know that this statement has got printed. Same way up to date. Once you'll see this particular statement, that means your simulation was successful. And then you can find out a file by the name simv. And then in order to have to open this particular file, you can just write this particular statement and then press enter, and you'll get the outputs printed on the console, right? So uh, let's see these steps in the server directly. So here is the environment file. This is how it looks like. So these are the fixed things that everybody has to do. Export is the keyword. Then novas_home is the home name of this particular, basically it is the environment variable name that we are trying to set here, right? So all these three lines, these and these, basically the LHS of the equal to first statement, second statement, third statement needs to be exactly same in your case also, right? Then we have to copy and paste the path of the VERDI and VCS tool here, right? So how you'll get the path of the tools, installed path of the tools. So in order to get this, you'll open the terminal. Once you open the terminal, just write which VCS. Once you press enter, you'll get a path of the installed directory of this particular VCS folder, right? And then till the version name, that's a version name. So till the version name, you will copy this particular path. Copy and then just go there and paste, like here. This way you will paste, right? So just like here, in my case, I have pasted it here. Sorry, here, right? The similar way you will do it for the VERDI. You will do which VERDI, and you will get the path. You need to copy this path till the version name, right? Again, copy and then paste it here, right? And if you'll notice that the Nova's home and VERDI home both are same. So you can copy the same path here in Nova's home also, right? So your file is now ready. So your environment file is now ready. You can just close this file. First, you can save that file and then you can close. Right. Once you have done this, then what you need to do is you need to source this particular file. So whatever is the name of your file, in my case, I have the name of this file as env underscore file. So I'm giving the same name. So source, then space, and then the name of the environment file. So I've given this name and then enter. So when the terminal start asking for the another command, that means your previous command is successfully run, right? So now my environment setup part is ready. So now let's suppose for an example, I have these two files that needs to run in VCS. So the first file is fulladder.v and the another one is fulladder tb underscore tb.sv. So that's a test bench file written in SystemVerilog and that's a RTL file written in Verilog, right? So in order to run the files on VCS, what you have to do is you have to write this particular command. But make sure wherever you have the files available, if you are doing it from that particular terminal, then directly you can write as I am writing. Otherwise, you need to give the path of the files where it is present, right? RTL file and the testament file. So in my case, it is available in VCS tutorial where my present terminal is here, right? So that's why I can directly take those files from here. So what I'm trying to do is I'm trying to invoke the VCS file along with those two files, right? So in order to do this, what command you need to type is VCS, then space hyphen S Verilog. Hyphen S Verilog is the switch that you need to use when you are dealing with system Verilog language. Otherwise, if you are dealing with Verilog, there is no need to add this particular switch, right? So in my case, the test bench is written in system Verilog, so I am adding this particular flag. Then the name of the files, right? So the name of the file is fulladder.v. So the first file. Then another file is underscore tb, this one. So all the files that you have for your simulation purpose, all need to be given here, right? Irrespective of order. But it is preferred that the order should be like design, then test bench this way, right? So once we have given these files, do remember these files does not have this hyphen before their name, right? So once you have given these two files, the next step will be hyphen LCA, then hyphen KDB, which is kernel debugger. It is important for VERDI, right? Then you have debug underscore access plus all. So the debugging and all the errors will get printed irrespective of the depth of the hierarchy that you have mentioned in your RTL design. It will have the access of all, right? So we have hyphen debug underscore access plus all, then hyphen full 64. So that's a full command to run the VCS, right? So let's just enter and you'll find out that your code is running and ultimately you will get this particular message. SimV up to date. So once you'll get this SimV up to date, that means the SimV has been generated and SimV is the simulation file which is responsible for carrying all the outputs of your simulation result, right? So once I'll do ls, you will get to know that you can see that's the file which is being generated after the simulation, right? So now this file carry the results. So if I want to see the results on the terminal, so what I had to do is dot forward slash simv and then enter. So you can see the results are printed here, right? So these are the results that got printed on a terminal. Now let's suppose I want to see the same results along with the waveform and the schematics on the VERDI. So what I need to do is dot simv dot forward slash simv then hyphen the space hyphen VERDI. So now the VERDI will get invoked and then it will It will take the SimV automatically. And now you can see that's how the GUI of VERDI looks like. And now you can start the simulation from this particular run simulation. And that's how the simulation occurred. And here is the results, similar to the ones that printed on a console, right? Now, in order to see the schematic, what you need to do is you need to click on this particular item, this icon, if a new schematic, right? So once I click here, you can see here is the schematic of it. Just make it larger, and then once I double click on this particular full module, I'll get this. Since it is written in a behavioral modeling style, so it is looking like this. So that much depth only you can see right now, right? So if you would have written it in terms of gate level modeling, so you would have seen the gates, the connections of the gates, right? That way. So the abstraction level of each modeling level, each modeling is different. So that's why the schematic of each modeling style is different, right? The depth is different. So you can just enable the properties from here. If you can see the properties from here, right? And then if you want to see the instance port name and the input output port name. So in order to make them enable, I have done this thing, right? From view, you can do that, right? Okay. So now we have seen the schematic part. And if you want to see the waveform, so you need to click on this particular icon, which says new waveform. And then you will click on the waveform part. You go to signal and get all signal, right? And then okay. So you'll find out that all the signals get printed here, right? And then you can just zoom in, zoom out, zoom in, and then slide left side. So you'll get this kind of waveform, right? So that's a waveform. These are the name of the signals, and these are the values of the signal, right? Now, in order to change the radix of a particular signal, you can just right click and set radix, and it is right now in hexadecimal. Let's say I want to convert it in decimal, so I have converted it in decimal, right? So that can be done for any of the signals. If you want to specifically choose particular signals, I don't want to see all the signals in a common window. I want to select each of them. So in that case, you don't need to click on get all signal. You just click on get signals, and the similar kind of the list of the ports you will be seen. You can see here, right? So if you want to choose any specific uh, signals, so you can just click on them. 1, 2, and let's suppose 3. Let's suppose I just want to see all of these, only these 3 signals. So I'll choose all of them, 1, 2, and 3, and then apply and OK, right? So that you can do. So along with this particular waveform, the must know information is that this particular waveform will only get created when you have FSDB statements written in your code, right? So what are those FSDB statements? Let me just show you. Just like in my case, I have written 2 FSDB statements here. These are the 2 FSDB statements which are responsible for production of this particular FSDB file, right? So FSDB is a file which is being produced by only these 2 statements, and that FSDB stands for fast signal database, and that FSDB file is the file which is responsible for carrying the waveform that we have just logged in the VERDI, right? So if you are unable to see the waveform in the VERDI, just first check for these 2 statements, whether you have included in your code these 2 statements or not, right? If you don't have these 2 statements, then you will not be able to see the waveform, right? And if during the simulation time, you have some error related to FSDB dump file or FSDB dump vares, then you need to check your environment file. You must have forgotten to source your environment file, right? So just think it in that way. Okay, so that's all for this session. We have learned how to run VCS, and we have seen the result in VERDI, right? So now I expect that whenever we'll write a code and we'll start simulating it in VCS, we don't have to worry about the tutorials of the VCS. So that's how the VCS and VERDI run. Thank you.